now we have the streamlines. The second post-processing skill is to get the velocity profile. So for our example, I want to visualize the velocity profile at around here. Okay, so let's see how can we make it. First of all, we need to go to the derived parts again. We can right-click, new part, and we will set a probe. The probe is a line. Okay, so now you can see the default line is this, and now we want the line located at the middle plane and also vertical line and passing through the roughly the center of the separation bubble. Okay, so what we need to do is you can see the input part is already set up as a default. So we need to set up point 1 to endpoints. Point 1 is let's say x is about 1 meter, right? And y is -5 or -0.5, and z is 0.5 because it's in the middle plane. Thus the y-axis, y coordinates is -5. The height of the stair is 0.5. X, 0.2x is the same, and y should be 1 meter high, and z is still 0.5. Okay, so now let's have a better view. So you can see now this is a vertical line, and this determines how many points are there. Let's see, we can have 25 points. So we will new service displayer, create a new service displayer, and you can see the 25 points are already shown. Okay, we can close it. These are the points to extract the velocity profile, to extract a velocity component actually, and then we can plot the velocity profile. So under the derived part, we can see the line probe. We can also make changes now, but we're not changing it. And then in order to make the velocity profile, we need to go to plots, right click, new plots. We want to generate XY plot. Okay, so this is what we have. Now x is direction, y is a function. Because velocity file usually x is the function of velocity magnitude, and vertical is the height. That's more intuitive. Okay, so what we are going to do now is to set x as the, not instead of direction but scalar, so it will be the function, and y we want it to be the direction. Is that right? And because y, there's another thing. So let's first set the x function, and we know it's velocity, and let's use the x velocity. So here's a velocity magnitude, but if we use the x velocity, and we can see the negative velocity magnitude, right? And for y, it's because it's a long, y should be 0, and then y in here. So this is y direction, and then we need to attach it to a attach it to the flow regime, and then we go to the scene and plot x, y. So it is velocity already, and we need to do the attachment. So we go to XY plot at the beginning, and then the parts need to is emptying here. We need to choose the derived parts. Line probe, that's a line and it has 20 points. Okay, so now you can see the velocity profile. So this is the height of y-axis, and this is the velocity u velocity, and you can see. And here is 0, and we do have a negative velocity. So, and here is a velocity profile in the mainstream, and then that's a separation bubble. Okay, so that's the height of the separation. Now we can see how to plot velocity profile. And so far we've finished the case of the backward facing step flow. We should now be able to simulate such a flow and also do some post-processing.